All right, Chicos. Oh no, I didn't clear everything.
I didn't see it
It's
anyway.
all good. It won't make any sense right now anyway.
Is our writing final on
It's on December 1st.
paper though?
Yeah, paper. That's why it's called the writing final. Because you got to write on it. No, we've done it. We've done it before. We've done it. We've been doing it for 2-3 years now.
How come we never have tests on paper to practice just for that? Because like every test is on computer, and sometimes.
You're supposed to be doing all your work on paper.
Well, yeah, I know, I do, but I just like.
All right, let's do this, man. 6.8. We're actually jumping to the end because it's an easy section, but it's a very important section. And I want to make sure that you guys can still do this. Not still, I shouldn't say that. I know you guys can do this, but we don't want you to forget. And we want to make sure that we assess it tomorrow during the quiz. About 10 questions. Remember that? Don't forget. Make sure you get your study on tonight. The homework tonight does have some questions from what we did Friday, which was simplifying radicals. And you should get a few of these today as well. It wasn't too crazy. So, there. All right. Now, take a look at the slide I have up here. The first one, these are the family of radical functions. You guys should already recognize this as being one of the parent functions, right? Which is y equals the square root of x. So that's pretty much it if there's a square. And of course, if there's a cube, we'll take a look at that, what that looks like. But that's why we have the nth root. Because anything above that is going to look a little bit different, okay? This should not be anything new to you. If you put a negative all the way in the front where a is supposed to be, what happens? You get a reflection on the x-axis. So that's what that's saying. Now, what if I make a bigger or smaller than 1? Stretch or shrink. When is it a shrink? When it's smaller than 1, but greater than 0. And it's a stretch if a is bigger than 1. So that's what that slide is saying. And then finally, you have at the very bottom, h and k. Which does what? What does k do? K is a vertical. It's up and down. What is h? Horizontal, side to side. Now again, notice there's that built-in negative there. So don't go with the idea that whatever you see in the h position is going to be it, right? So just remember kind of the opposite of type thing. Right, Joe? Okay. Any questions on this slide? Again, all stuff that you've already seen. Okay. Translating vertically. I'm just going to run some sketches real quick because I really don't want to spend too much time on this. That first function says y is equal to the square root of x minus 2. Here's the square root of x. What does square root of x minus 2 look like? I know that's not exact, guys, but you get a good idea of it, right? Here, let me show you what it does look like exactly. There's the, let's go to decimals. Oops, that was way off. That's a decimals. If you want to do a radical, you got to go miscellaneous, square root, and this one actually wants you to put the 2 in there. If you don't, it won't do it for some reason. But there's what it looks like. There's what the radical, the square root of x looks like. What? Yeah, but I just want you guys to do it. I want you to think about it. So, going back to here, let's pretend that this was the original function. What would square root of x minus 2 look like? Damien, what would it look like? Welcome back. Here is square root of x. It would exactly the same, but 2 units down. Correct. So it would look like that. What about the other one? Yeah, it would look exactly the same, except it would move up 1 unit from the original part. So it would look like that. Questions on this slide? Some people are still writing, so I'm not going to gauge you yet. those all purple Fruit Loops?
The only O's.
Oh. They look like, from here they look like you collected all the purple Fruit Loops from the box. Right?
Yeah, probably not that.
Those are good. I love me some Fruit Loops. What's up?
That black line, is that there when it starts?
That's supposed to be the parent function. I was saying, if this is the square root of x, the parent function, then what do the others look like compared to that? Well, the red one should be moved down 2 units compared to this one, right? And the green one should be up 1 unit compared to that one. So the black one is just the parent function.
And what's the parent? Oh, that bracket y.
Y equals radical x is the parent here. Okay? We're good? Alright. Same idea, right? What's the first one look like? The whole thing is shifted up. Guys, it's 2 days and you got a quiz tomorrow. You can't afford not to pay attention.
What is it?
Thursday, Friday, and this. Transformations. You guys good, or do we need to do these? I'm looking out in the back. My little wallflowers over there. Show me thumbs up if you want to keep going. Alright, moving on. Alright, so translation horizontally. Here is, what? I thought I made these a little bit bigger. Wow. So here's some horizontal ones. Let's pretend this is the mother function here. What does the first one look like compared to that? 4 units to the left? Aha, nice, you beat me to it. There's a plus, so 1, 2, 3, 4. There's my, I don't want to say it's my vertex, but it's my lowest point. We'll call it the vertex. Boom, there it is. Okay, what about the other one?
Is it a positive one?
So 1 unit to the right. Boom, there you go. Questions on those?
Always forget there's both a negative.
Don't forget, you can't forget. If you forget, you fool. You're wrong. You just lost points.
Been losing points.
Any questions on this slide? Show me those thumbs then. Thank you. On the right side of the room, how about the left side? Processing, processing. Go ahead.
Would we be able to use Desmos for this?
Maybe. Why would you want to?
Well, I mean, just.
No, you could. But I guess my question is, why would you want to? Wouldn't it take you much longer to type that in than to just?
Well, I don't know, just in case, like, if I'm forgetting a step, I'm just like, oh, I just,
Want to verify?
yeah.
But shout. What's that?
So I don't understand why these
Okay, look at where the 4 is. You see how it's inside the radical? That's the H position. See the numbers here? They're in the K position. They're on the outside. Kind of like when we had parentheses, remember? Remember when we had y equals ax minus h squared plus k? H is inside, k is outside. Same thing. Except we don't need parentheses because we got the symbol for radical, don't we? Okay? Thank you for asking. Alright, left side of the room. Technically the right. Show me those thumbs now. Are we good? That's a poor turnout. Double thumbs. Just show me the next one already. Alright, let's start this one here quick, Karen. What's that going to look like?
Right.
This one is 3 to the right, and this one is 2 to the left. Alright, let's put it all together then. Sketch me that.
Oh.
Sketch me that. Sketch it. Sketch it. Sketch it.
I know the general shape.
Sketch it. You gotta put it on paper because make a mistake, people don't write it down and be like, oh, I had that. Knowing very well you did not. Oh, I had that in my mind.
I can
Something
see it.
like that.
You fool, you're wrong. You just lost points.
I see why.
Nice job, though. You had most of it.
There.
I told you. I told you.
Oh no,
Boom, 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 boom. What's up? Yeah. A little bit lower. A little bit lower.
I'm just trying to make sure because I'm trying to mentally practice like so I automatically with
Good.
that.
All right. Let's tear this apart. Let's call that the original function. What should it do? To the right, how many? 3 because of this, right? So 1, 2, 3. And then?
Down one.
What?
Or up one, sorry.
Up 1. So it should be here, correct? So technically it looks like this. At that point, after the 2 red things I've underlined. Here's where you guys are kind of messing it up. There's a negative up front. There's a negative 1/2, right? So let's talk about the negative first. What's that going to do? It's a reflection on x. Which one is x? This one here is the x-axis, so I need to reflect on that. That means, yeah, if you were to fold it on that x line, it's going to flop over. So here's what I do. Because this goes up 1 unit from there, I'm going to just go down 1 unit from there. So there's my new point, and then it should dip like this. There's my reflection. Now, what am I missing? My shrink. Not necessarily dilation, because dilation would imply the whole thing is getting smaller, right? But because it goes on towards infinitot, yeah, so it's just going to be a shrink, so it's going to kind of do this bit, blah, something like this. And it's not exact, but you should get the idea, right? It's kind of getting squished. So it should just do, and I'll put it in blue. So the blue is your final image. Questions on any part of this? Right here. Be careful with your reflections. Careful with your reflections.
So what does the half stand for again? Like what part?
A is your vertical stretch or shrink.
Oh, okay.
When is it a shrink?
Is it a shrink?
Yeah. Ha ha ha! Therapist. Shrink, you're going to find it when A is less than 1, but greater than 0.
Yeah.
So in other words, it's the F word. It's a fraction. All right, we're good? Show me that fist of 5. How well you got all this?
I mean, like 4.5.
4.5? 3? What part?
The first part, the dilation, or the...
You mean the A business? Okay, so you got up to the red, right? Now, so at that point, let me get rid of this. What has to happen, because here you're good, right? Just double checking. We got to do this. The negative means it got flipped over the x-axis, right? So if you can imagine me just kind of like flipping it over to this side, right? Kind of like just flat. So what I do is I try to find that point. From this 3, I went up 1, right? So instead of going up 1, I'm going to go down 1 unit, wherever that is. And then the whole thing should also flip. So if it's kind of caving upward, this one should be caving downward, see? Just like that. That's what the negative does, just the negative. The half means I have to squish it. Now, I didn't do anything fancy. I just made it smaller because it's a fraction. Because we're just talking about it. Okay? But you'll be able to see that if they show you pictures and stuff of what's going on. So negative just flips it.
So negative is what we're trying to put
There's a question on the floor. The negative determines whether it flips it, and the answer is yes. But it also matters where that negative is. Let me show you this mother function. Here's y equals radical x, right? It looks like this. Okay? I'm going to use red. I'm going to show you another one. And it looks like this. Where is that? Negative. It's in the A position, right? It's outside. That is a reflection on the x-axis. So it's going to look like this. Okay? You okay there? I could also have the negative be inside with x. You see it? Do you see the difference?
Would that just be still up, but facing the opposite way?
Right. That's a reflection on the y-axis. So that image would go this way. You see it?
So if the negative's on the inside, it's on the y. If it's on the outside, it's over here.
If it's outside, it's on the x. If it's inside, it's a reflection on y. The question is, if I have them both, well, isn't a negative times a negative a positive? No, not here. That's not a parenthesis. That's a radical, isn't it? Those rules don't apply here. So that, my friends, would look like this. It'd be a reflection on x and a reflection on y. Math. You're so pretty. So pretty. If you have both negatives, yeah. That's your question?
Yeah.
Florida. Good morning, sunshine. Reminding me of my brother. I'm not sleepy, miss. I'm just looking at the notes in the back of my eyelids. Are we good? Moving on?
Wait.
I'm just putting my marker down. Relax.
Bless you.
I don't know what that was. I was taking a drink and I kind of laughed at the same time, and it went down my esophageal too. How about that? So I just found out there was a band called Portugal, period.
Did you watch the AMAs last night?
No.
Oh, that's how I thought.
It was on the radio, and we was playing The Weeknd, and then there was a suggestion for Portugal the Man, and I like that song anyway.
I didn't even know that was.
But like, man, what are we doing? Like, are we so out of names that we gotta write sentences now for our bands?
Wait, was it like the word Portugal, the word period, or is it just?
No, yeah, it's Portugal, period, the man. No period at the end.
Oh, that's.
Like, really? Yeah, why? The quadratic is an equation, period. That's my band.
Oh, smash a watermelon?
Grease is slippery. Experience beware. That would be great. Right? We period, the period, people period. Hey, that's not a bad name. No, we period. The period. People period.
There would be so many complaints about that man.
Why? We could just call it WTP. For short, right?
Disrespectful.
Are we not people? Homo sapien sapien. That's what we are. That would be good. Alright, moving on. Try this one. Try this one. You can do it. Grease! What's my function going to do?
-2. It's
It's gonna go down. It's gonna
That's kind of redundant, isn't it? Hold on. Try it again. How many to the left? Yeah. Saying negative 2 to the left is like negative times a negative makes a positive, right? So if I'm going the opposite of 2 to the left, I'm going 2 to the right. You see what I'm saying? So 2 to the left and then what? 1, 2, 3, 4. And then what? A stretch, so it'll do something like this, right? Maybe not that much, I'm exaggerating, but I'm definitely saying it should not be as squashed as the original one.
So, like, when you expand it, does it just go up 3 units, or does it go all the way up to 3?
Well, think about it. If you plug in a 1 for x, you should get 3 out because you're multiplying it. So if you move 1 on x, let's say this is the 1, the next one should go up 1, 2, 3. So it actually should be right about there.
You put it right there.
I know it's just a sketch, but you get the idea, right? Think about input-output table. If I put something in, what's going to come out? And that's a new coordinate on there. Okay. Thank you for asking. That was a good question, actually. Call me on my sketch. Call me out on my sketch. Now, this one's a little bit different. I don't know if you guys have seen a cube function. I have never shown you, not a cube function, what a cube root graph looks like. And it looks like 2 square roots. Let's see, let's go back to here. It looks like this black part with the green part. Do you see it? It has both ends to it. So let me show that to you. I'm going to take this index and change it for a 3. Go back. And that's what the cube root function looks like. The reason why there's a piece on this side now is because you can actually have negatives. If I put in a -2 for, or sorry, -8 for the cube root, what would I get out? If I took the cube root of -8, I would get a -2. So I can have negative coordinates here. Now with the square roots, just the cube root. So point is, make sure that you know that this is your parent function for a cube root. Okay. Now, if you ever forget, what are you going to do with the function?
Graph it.
Desmos! Throw in Desmos, figure out what it looks like. There's the 4th root again. Do you guys see how it starts getting flatter, flatter, flatter over here on that end?
Yeah.
Kind of like the quadratics do. Go 5th. Flatter, flatter still.
So are all the odds kind of like that S shape?
Yeah, just like cubes. Just like exponential ones. The even ones always go up, like a U shape. All the odd ones do, what would you call that? Okay. Something interesting, since you're saying it. You know how the cube function looks like this? X cubed. The inverse is taking the cube root, isn't it? That's why the graph looks like, oops, I missed it, didn't I? It's kind of like taking that and it's the opposite of it. I don't think I did that very well. But yeah.
So
It's-
that one's going like that.
It's that same image twisted kind of. Yeah.
And that was going like that, and that was going like that.
Yeah, and we'll do those later on. We're going to do inverse functions later. So it's good to know that and to notice it right now. That's horrible sketch. Let me try that again. Actually, you know what I'm going to do?
Yeah, just type it in.
Yeah, exactly. So here's that one. And then here is x to the 3rd. See how they're reflections of each other?
It's like a little infinity sign.
It does, doesn't it?
Figure 8.
Now here's what's cool about those. If you have a function and you know it's inverse, you will always end up with a line that goes right through the middle. Like if I was to add these all up, guess what I would get? Yeah, I would get the function x. See how it goes right through the middle? Ah, that is so cool. Sorry. I'm going to get back to the lesson. So, it's simply that cube function has been moved to the left 1 unit, down 4 units, and it's been compressed by, sorry, not compressed, stretched by a factor of 2, right? All right, I got to do one more thing before we go. Simplifying that. You guys see this function up here? You might have to sketch it without, sorry, how do I say this? They might ask you information about it without a calculator. I don't want you to fully depend on that. There's some things that you need to know how to do. So let me just walk you through this real quick. It's not even a big deal, okay? Because here's one thing that Poly Decimals won't tell you. Okay, you guys ready? Does this function have a vertical stretch or a shrink?
Neither.
It doesn't have A. Wait, what? Is it all?
It's 0.
It doesn't have. Oh wait.
Isn't it still
It's 1.
Decimals can't tell you that. You can ask it, it'll graph it, but you still probably won't figure it out.
So it only has
So wait, what would the A be then?
Let's take a look. You guys want me to just punch into Decimals? People like Munoz don't want me to try, that's all.
Well, I mean,
I'm saying go for it.
I'll trust and say that.
So let's see, what was it? The square root of,
9x.
square root of
9 minus.
9
Plus.
plus 18. There it is.
Oh, because so
Squared? Did you square it or what?
so when you do those, you have to put the
Is it just 9?
So you use the one.
Wait a minute, is it
that's
one of those
wrong.
things where you automatically
So take a look. Does it even make sense to what you have?
No.
There's a shift of 2, isn't there?
Yeah.
So let me just show you. It's not even hard. Okay?
Oh,
So
because it's that thing where you automatically assume that it's 2.
take a look at the inside. Aren't both of those? Don't both of those have a factor of 9?
Yeah.
So if I factor out 9, I would get x plus 2, wouldn't I? Oh, look at that too.
That's
Show
Okay, now, are we good here? Show me those thumbs. Thumbs up or down.
So you just like factor.
I just factor out a 9. They both have 9 in common. I factored it out. Here, what's 9 times x? 9x. 9 times 2? 18. So I just factor out a 9. Now, the 9 in this binomial will be multiplied, right? So I can rewrite this as the square root of 9 times the square root of x plus 2, couldn't I? Same thing. What is the square root of 9? 3. So this is really 3x plus 2. Does this have a stretch or a shrink? It does, doesn't it? A stretch of 3. Is there a vertical shift? Well, if they ask you questions about, like, does this function have a stretch or shrink? What is a shift? Because a lot of people will say, oh, did this get shifted left or right? How many units? And people will be like, oh, 18. And no, it's wrong. You just lost points. You fool. So, you see how at the end I've got 3 times radical x plus 2? And I go back to the graph, look at that. There's my 2.
Wait, so then type in 3 to the square root of x. Yeah.
What?
Just type it in. I'm curious.
Type what in? The new one?
3 to
Oh, it's going to be a line on top of that one. Here, I'll show you. So 2, right? I need a 3 up front. And this should say x plus 2. Math! Now, I want to answer your question. You know how you're asking me about the stretch shrink? How can I tell from drawing the picture? Well, if I ignore the stretches and the shifts, I've got the square root, right? So if I pick x to be 1, that's a movement of 1. So I'm going to move 1 unit to the right. Okay? That 1 is getting stretched by how much? You can't ask me the question, not pay attention. You were talking about stretch and shrink, yes. So I moved 1 unit, but that 1 unit got stretched by how much? 3. So if I go up, what is this? 1, 2, 3. Look at that. I'm back on the graph. And that's how I know how to do how slopey it is. Even though slopey is not true, it's not a real term, but people make sense from it. Questions? Are we good? Are we good now? That's all I've got, guys. Homework is ready. Make sure you get it done. There's stuff on there from